Okay, for this problem, the first thing I'm going to do is find the magnitude of A. Find the magnitude of A. By the way, I need to mention this to you. Sometimes I'll use single bars. Sometimes I might use double bars. I think throughout the years I've seen it both ways. They mean the exact same thing. One time on a test I had maybe the single bars and maybe I'd been using the double bars in class, and there were students who left it blank because they didn't know what it meant. It means the same thing, so I have to say that. So the magnitude of A is going to be the square root of 5 squared plus -2 squared plus -1 squared. So that's the square root of 25 plus 4 plus 1 is the square root of 30. I'm just going to leave it square root of 30. So for part A, a unit vector that's in the same direction of A would be this, and I guess I'll call that one U, would be vector A, which is vector 5, -2, -1, divided by the magnitude of A, which is the square root of 30. Now, that square root of 30, I can put it with each component. So that's 5 over the square root of 30 for the first component, -2 over the square root of 30 for the second component, and -1 over the square root of 30 for the third component. There's the answer to part A. If you left it like this, I'd probably take that on the test. The grad students would probably take that answer. I'm kind of curious what the computer would, if the computer would take that answer. Now for part B, I want a unit vector in the opposite direction of A. What do I have to do? Multiply by -1. Multiply your answer in part A by -1. So -1 times 5 over the square root of 30, then -2 over the square root of 30, -1 over the square root of 30. So -1 times that vector. So really, you could have just changed the signs of the components in the vector from part A. And for part C, I want a vector that's in the same direction as A, but has a length of 3. So what I would do for part C is multiply U, the answer from part A, by 3. And then that will give me a vector in the same direction of A, whose length is 3. So that's 3 times the vector 5 over the square root of 30, -2 over the square root of 30, and -1 over the square root of 30. So that gives me the vector, the first component's 15 over the square root of 30. The second component is -6 over the square root of 30. And the third component is -3 over the square root of 30. I'll go back and box the answers.